Alright, hello once again. This is Jeff Scott of Blackhawk Technical College. I'm now about to start a series of PowerPoint presentations for the online version of 152-147 Relational Database Development for the Spring 2016 semester at Blackhawk Technical College. Our book is Murox MySQL, second edition, and I'm got the, like I said, the associated slides up. Now it's going to be interesting because the slides that I have are from the first edition of the book. For some reason I don't have the second edition stuff available, but they should be virtually the same. So alright, so here's our objectives. It's not my goal, as always, to sit there and read to you, but let's just talk about the things that are the most important on here. The third bullet talks about some of the typical jargon that you're going to come across with relational database management systems, those being tables, columns, rows, cells, primary keys, and foreign keys. We will talk about them. We will also get into the three types of relationships that can exist between two different tables, those being one-to-one, one-to-many, and many-to-many. But again, like I said, it's not my goal to sit there and go over every word that's on every one of these particular presentations. So, all right. We'll look a little bit at some entity relationship diagram stuff. The second bullet that's on there describe the differences between data manipulation language, DML, and data definition language, DDL. That's amongst the most important parts of the entire book, so we will spend a little bit of time on that. Alright, so first thing they talk about here is they start to mention a client-server type of system. With a client-server, virtually everybody, so imagine that in room 1509 at Blackhawk, we were all using the same version of MySQL. That's not the way that it's set up, but let's just pretend for a minute that it would be set up that way. Then the database server would be the machine that you see there. Our machines would be physically tied to that database server through some kind of a local area network, and each one of our individual machines would be clients in that kind of a setup. So I've just kind of gone over that, and just so you hear that, the difference is, they talk about some terms to know here. And a local area network is where literally there is a physical connection between machines. So we have local area networks set up at the Blackhawk Central Campus. On the other hand, there are connections that are between the Blackhawk campus at in Janesville and the Blackhawk campus in Monroe. Well, it wouldn't make sense to literally run wire throughout, cross Highway 11 or whatever, all the way from one to the other. So that's a wide area network where there is no physical connection that's actually there. All right. They're making this look really simple too, because just so you know, a lot of times what happens is you as a client, you initiate some kind of a request. In this case, it'll be through an SQL or a structured query language query. And it may go right to the database server that may handle it and send it back. It may just go out to another server, and that server may figure out which server to send your request to. So they're making this look really simplistic, where indeed it may or may not be that simplistic. What we'll be working with in this class is MySQL. MySQL is a DBMS, as they mentioned right there. It's a database management system. There are others, some of which you pay for, some of which are free. MySQL is free unless you want MySQL help, and the help costs money. For years, MySQL was an open source relational database management system, meaning that basically no one owned it. And in some ways, it is still that way, in that it's open source, but it is now owned by Oracle, who also owns Java. There are equivalents to MySQL. There's SQL Server, which is Microsoft's product. There's Oracle, which I already mentioned, and there are other ones as well. Now, they mention here that the database management system does the back-end processing, so it does a lot of the behind-the-scenes work that you don't typically see. You get the results from it, but the work that's being done is being done behind the scenes. All right. So they talk about application software. Well, that's what this whole program is about. The IT web software developer program is about creating and learning how to create application software. All right. In order to be able to use the MySQL application software, you need an API. An API is an application programming interface. And the API is basically, it's the software that allows you as a user to communicate with the relational database management system. I'm being fairly simplistic here. Okay? All right. So the DBMS does the back end and the client software does the front end. One of the, you're learning a lot of back end stuff this semester, but come fall of 2016, you'll be taking a class in PHP where you learn more of the front end side. So this is more of what I've just already told you, okay? And just so you hear this, and you probably did last semester, but just in case you didn't, SQL, as it says, it's an acronym that stands for Structured Query Language. Some people read it as the word SQL. Some people just call it SQL. It really doesn't matter. But SQL, even though it stands for Structured Query Language, it's a standard. In other words, it's something from which other languages are based off of. And the reason that that's important is if you learn how to use SQL for MySQL, then learning how to use SQL for SQL Server or for Oracle won't be nearly as difficult because they're very similar. There are syntactic differences, but the theoretically they're basically set up the same way. All right. With a client-server system, as it says, the processing is divided between the client and server. With a file handling system, all the processing is done on the clients. So they show you some pictures and stuff in here. This is what I mentioned to you before, that typically the database server isn't going to be something that your client is going to literally just ask information of. Rather, they'll request something that will go to an application server that will funnel it off to a database server, which will send the results back to the application server, which then sends a response back to the client. All right? And they show a web-based system. The difference that's in here is instead of calling it a regular server, they call it a web server. And yeah, the internet is involved. All right. Application servers store business components. We get into that, but just not really much this semester. Web servers store web applications and web services. This, again, I'll run through this, but I want to do it kind of quickly because to me, that's not what this class is about. All right. So how does a web app work? Again, the user from their client machine keys something in to their address bar, all right, from their browser. And when they hit enter, that sends a hypertext transfer protocol request over to a server someplace, typically a web server, which will process the request. If necessary, that web server will call a database server. And if a database server is called, the database server will do its job, return the results to the web server, which in turn will return a response, an HTTP response, to the browser. So this is the kind of stuff we're going to be looking at this semester. All right? Now, the only thing I'm a little confused about here is why they have two sets of numbers. And it's really not that important a thing, but the thing to realize is you've got vendor ID, vendor name, vendor address 1, vendor address 2, vendor city. Let's suppose for just a second that's everything that's in this table. Let's suppose this table is complete right here. All right? What that means is we have 1, 2, 3, 4, 5 fields. You can see their names. We have 14 records or rows. All right, so as you go across, they're fields. As you go down, they're rows. All right, and since we have 1, 2, 3, 4, 5 fields, and since we have 14 records, 5 times 14 means that we have 70 pieces of data in here. Now they call these here, they call them columns, they're typically referred to as either columns or fields. Rows are typically referred to as either rows or records. But let's keep this real simple. A primary key is a unique record identifier. So in other words, every one of these vendors that we have here, every vendor that you see has a different vendor ID. So you can be sure they're unique from one another. All right. And also notice that every vendor has a name, has an ID, has a name, has an address 1. But notice for some of the address 2s there, they're null, which means, for example, the U.S. Postal Service here, all right, that one has a second address, a P.O. box. But if you look at the national information, whatever, it's got a P.O. box, and there isn't a second address. So null means the absence of a value. There literally is nothing there. Some of the terms for you to know, well, what we'll be creating in this class are relational databases. Relational databases are made up of tables. Tables are made up of columns. Columns are made up of rows. Rows are made up of cells. So let's just take it from the top. Let's imagine that I've got a field, okay, which we could call a column right here, and we decide in that field we're going to put in a person's middle initial. So we literally call that field MI for middle initial. Now, some people don't have a middle name, so in that case, they wouldn't have a middle initial. All right, so that column, it wouldn't be mandatory that you put a value in there. But if you do put a value in there, it can only be one letter. The reason I'm telling you this is that a column or field can be as small as one single letter. And there may be very good reasons for a column to be just exactly that size. All right, if you take one or more related columns and you put the one or more related columns together, you get a row or a record. So you saw here, as we look back here, well, and now this isn't letting me go forward or backwards to go on this. This thing is stuck. So I can only go in one direction. Now I can't go back again. But, well, let's look at them from here. All right, we've got our primary key, our unique record identifier. All right, and that's one field or column. We've got vendor name, which is one field or column. We've got vendor address, which is one field or column. Vendor address 1. Vendor address 2, which is one field or column. Vendor city, all right, you can see it's a little bigger than what we saw before, and that's one field or column, and vendor state, it looks like. All right. Again, the key takeaways here are a primary key is a unique record identifier. Tables are made up of different columns, which we typically call fields, and when you put together each one of those fields, they constitute a record. If you put all the records together that belong together, that constitutes a table. If you put tables together that are connected to one another, okay, then that's going to be your database. Now, if you notice in this example right here, they've got something that's called foreign key. So in other words, they've got two different tables here. One table that has vendor information and one table that has invoice information. But you'll notice if you take a look at it, we have two different primary keys. The primary key in our top table is vendor ID. The primary key in our bottom table is invoice ID. It is not vendor ID in the bottom table because we've got 123 in there several times. And remember that a primary key is a unique record identifier, so each primary key has to be unique, like they are here and like they are here. So why did we add vendor ID to this table? These all say invoice, and why does that one say vendor? It's so that we can relate these two tables together, because now these vendor IDs that you see right here are going to relate to these vendors that you see up here. And this relationship between the two tables is the key or the hallmark to what's involved in relational database management systems. So I just showed you a foreign key, And a foreign key typically, let's go over the relationships first. All right. When you look at these three relationships that are here, there are three that are listed. One-to-many relationship, one-to-one relationship, and many-to-many relationship. Now, in an ideal world, if you are setting up a database, you want the relationship between all of your tables in an ideal world to be a one-to-many relationship. That's what you want. That means that one record in one table will relate to 0, 1, or more records in another table. So the one record is the one side, the 0, 1, or more is the many side. That's ideally what you're going to have. Sometimes what happens, though, is you create a situation where you've got a table. So let's say I'm doing a table about a person, and I put in their first name, their middle initial, their last name, their address, their city, their state, their zip, their home phone, their cell phone, etc. That's already 9 pieces of information. But now I decide I want to put some more information in there about a person too. I want to put in their height, I want to put in their weight, and I want to put in their eye color, and I want to put in their hair color, etc. Well, rather than having one table that might have 20 different fields in it, I might decide to break it up into 2 different tables. They're all still information about one person, but I've now put it into 2 different tables. All right? I didn't have to do that, but I did it because it's easier for me to work with. That's a one-to-one relationship. And then finally, you've got a many-to-many relationship. And a many-to-many relationship is not directly supported in a relational database management system, and you'll see that in examples we'll go over later. All right? So let's talk about foreign key and referential integrity. When you set up a relationship that's a one-to-many relationship, okay, and you take the primary key, the unique record identifier from the one side of the one-to-many relationship, and you add it as a field in the many side of the many one-to-many relationship, that's called a foreign key. All right, and if that doesn't make a lot of sense now, don't let it worry you, because we're going to be going over it as we go on. One of the reasons that you have a foreign key and you have a setup like this is you want to be able to preserve what's referred to as referential integrity. And what that means is when I've got tables that are involved in a one-to-many relationship, what I don't want is I don't want to be able to remove the record on the one side if that record still has entries in the many side. In other words, I don't want to be able to remove a parent record while there are still associated child records. All right, and again, if that doesn't totally make sense, that's a lot of what this class is about. So we will be talking about it over and over again. So here's an example of a table. This is an invoices table. This is the kind of thing you're going to learn how to create in here. And it really, I don't know if you look at it and you think it's difficult. It really is not very difficult, though. All right, and I believe when they're doing it here, they're using SQL Workbench, which is what they use in the book. It's not what I'm going to use. All right, not to confuse you, but there are other products out there that I think are easier to use that I know better than SQL Workbench. All right, some of the common data types that you use. Notice the first one says char. That means a fixed character length. So if I had a state field, and I said my state field was going to be size 2 for a state abbreviation, like WI for Wisconsin, I'd say char, and then in parentheses, I'd say 2, which means it can have either, it's a fixed size. Char means a fixed length. So it could have either 0, 1, or 2 characters in it. On the other hand, when I've got an address, I might make that a varchar. The V in there means variable. So it's a variable length field. Some people might have a small P.O. box address, P.O. Box 123, that only needs 5, 6, or 7 letters. Somebody else might be 1, 2, 3, 4, 5 North Farmington Way, apartment 6, something like that, which needs a lot more. We'll talk about int and decimal. Int meaning whole number, decimal meaning it can't have a decimal place. And there's different variants. For example, other than decimal, you can have a float also. We'll talk about that. And we'll talk about dates and how they're stored in this language. Terms to know. Well, we just talked a little bit about these data types. and mention some of them. I think it's chapter 8 in the book is all on the different data types that exist in MySQL. A null value, null means unknown. So if you allow something to have nulls, what that means is it is possible for that value to have an absence of a value. All right, default value. Well, imagine I was creating some kind of an application for Blackhawk. I might set the default value of the state to WI because probably 99% of the people who come to Blackhawk, if not more, are from Wisconsin. You'll also learn in here about what's called an auto increment column. And a lot of times what that is it'll be a special column that you make up. You saw vendor ID and you saw invoice ID. Sometimes you'll just make up a field that's called ID. And you'll set it up as an auto increment field, which means the first record you put in will have an ID of 1. The next one you put in will have an ID of 2, etc. Now, this is what's called an entity relationship diagram right here. And what it's showing is relationships between different tables. All right? So, for example, when we look at this, you'll notice that many of these things have what are called crow's feet. That's the many side. And where you see the non-crow's feet, where it kind of looks like a railroad track, that's the one side. All right, so for example, one vendor, 1, may have 0, 1 or more invoices. One invoice may have 0, 1 or more line items. So we'll go over some of this stuff again as we go on in the class. All right. This is a little timeline in the history of SQL. The key thing is, if you notice in here, SQL itself was actually created in 1970. Now think about that. That means SQL is going into, or the relational database model is going into its 46th year. If you think about where computers were in the year 1970 to where they are right now, it's a big difference. There was no internet back in 1970. All right? But even products, for example, Microsoft released SQL Server. Okay, so if you notice, that's what, almost 30 years old. All right, so a lot of this stuff is not very new. Oracle, 1979. All right, so what is that? 21, just about 37 years old. MySQL became open source 15 years ago. Oracle acquired Sun Microsystems, which is Java, and MySQL. And previously, Sun had acquired MySQL. So when Oracle acquired Sun, they acquired both Sun and MySQL. Some of this right here is what I mentioned to you before. Basic SQL statements are the same, regardless of whether you're writing an SQL statement for Oracle or MySQL or SQL Server. So once you know one, the transition to others is not that difficult. All right? And then they say most applications require modification when moved to another database. What they're saying is, if I write myself an application that's going to run solely for MySQL, and then later I need to move it over to SQL Server, I'll have to make changes in my code. All right, a little more history here. If you look up here on the screen, I'm going to do these in reverse order and talk first about DDL. DDL is Data Definition Language. And they have data definition language has to do with what are called database schemas. So that's behind the scenes, and you're going to see this very shortly of what the data looks like. Notice that there are 3 DDL statements. They are create, alter, and drop. And anytime you're going to say to create something or alter something or drop something, you have to let the system know what kind of object you want created or altered or dropped. In other words, as they show in the examples here, do you want to create a database, or do you want to create a table, or do you want to create an index? Do you want to alter a table or an index? Do you want to drop a database or a table or an index? So all these three DDL statements, all right, they all work with what's referred to as the database schema or the internals. You're going to see all this stuff as we go on. On the other hand, there are also DML statements, and as you can see right here, there's select, insert, update, and delete. Sometimes you see these things referred to as CRUD, C-R-U-D, for create, read, update, and delete. All right, where create takes the place of insert and read takes the place of select. Those statements, those 4 DML statements that you see right here, all right, they work as far as manipulating the database data itself. And again, that's what this class is going to be about in many ways, is working with the different MySQL, DML, and DDL statements. So if we wanted to create a brand new database, we could do this. Create database AP. If we wanted to activate that database or make it the current database, it's use AP. I do want you to realize that SQL, structured query language, regardless of what relational database management system you're using, whether it's MySQL, SQL Server, Oracle, or something else, what they're showing here, the keywords are in uppercase, and what's not a keyword is in lowercase, but the language itself is case insensitive. So we could have made everything lowercase, uppercase, or mixed case, and it would still work fine. So here's an example of a statement as it says that will create a new table for us. This is the kind of thing you're going to be learning in here. Well, what can we tell from looking at this? Let's just take it from the top. We know it's a table. We know that its name is Invoices, and we're going to create it. We also know that everything that's within that table will be within this parenthesis and this parenthesis. Okay? So we're saying the first field that we have in here is going to be called Invoice ID. It can only hold whole numbers, and it'll be our unique record identifier. Also, have it start with 1 and automatically increment for us. Then a comma, then our next field, Vendor ID, which is again going to hold just whole numbers, and it can't be null, so there must be a value in it. Invoice number, which is a variable length character field between 0 and 50 characters, again cannot be null. A date, which is a date field that cannot be null. An invoice total, a payment total, and a credit total. You'll notice that each one of these three say decimal 9,2. That means that there can be at most 9 digits. 999, 999, 999. And the last 2 will come after a decimal place. So we're talking what? 9,999,999 dollars and 99 cents would be the maximum amount you could have in there. And if you put nothing into those fields, have them default to 0. The terms ID is another integer that can't be null. The invoice due date can't be null, and it's a date, the payment date. The stuff down here that says constraint, those are extra constraints that we're adding. So what we're saying here is that we're going to create a foreign key on this thing for our vendor ID that is going to be referencing the vendor ID in the vendors table. Okay, and again, if that doesn't totally make sense, we're going to be going over that in a lot of depth and breadth of coverage. Here are some examples of data definition language statements. You'll notice there's an alter. All right, there's a create and there's a drop. Okay. This is one of the tables that we're going to be working with. We're going to be doing a lot of work for several chapters on what's called the select statement. And the select statement allows you to view data. Not change data, but view data in any order, etc., in which you want to show it. So let's take a look at this one. This is a query right here. So what we're saying is we want to grab information from two different tables, both the vendors table and the invoices table. And these are the fields that we want: vendor name, invoice number, invoice date, and invoice total, from these two tables. And in order to do that, they have to have a field in common so we can do what's called a join on these tables. So show us the vendor name, invoice number, invoice date, and invoice total, but only where the invoice total is greater than or equal to 500. And then put it in physical alphabetic order based first on vendor name, then on the invoice total, and the vendor name will be in ascending order and the invoice total will be in descending order. So you'll notice right here we've got two things from Ingram. All right, so what order are they in? Well, since the name is the same, it goes to the next field and it says, give me the invoice total that's the highest first, and you can see that right here. So these are terms that you're going to have to know. Query, you ask the when you ask the database a question, you're querying the database. When you query a database, you get a result set back. All right. The tables that you'll be working with are your base tables. You can calculate values in your queries. You can join tables together, and there's different ways of joining tables together, including inner joins and outer joins. This, again, is all information that we're going to be going over into later, getting into in later chapters. Here's how we can add. So this adds a record to the invoices table. So this says we've got vendor ID, invoice number, invoice date, invoice total, terms ID, and invoice date. 12 becomes the vendor ID. 3289175 becomes the invoice number. 2011-07-18, that becomes the invoice date. 165 is the invoice total. 3 is the terms ID. And 2011-817 is the invoice due date. You'll notice that some of these fields are in quotes, which means they're strings, and some of these fields are not in quotes, which means they're just straight number fields. All right, so that was an insert. We're also going to learn how to update stuff that's in a database. And here's a couple of examples. I don't want to go into them in too much depth and breadth of coverage because, again, we've got entire chapters on this stuff that we'll talk about later. And so you can insert, you can update, and delete. In addition, if you just want to see the data but not change it, you can use a select statement. They talk in here about using some white space to make stuff easier to read, because this statement here and that statement right there are the same thing, but the second one is much easier to read. You can also add comments if you want to. You add comments the same way we've been adding comments in multi-line comments in JavaScript, for example. Single-line comments are now not a slash slash, they're a dash dash. All right, so a single-line comment is 2 minus signs. This is the author's suggested coding recommendation, especially as you're learning this stuff. I don't see anything wrong with anything that he's come up with, but you have to do what's most easy for you to learn and understand. The author suggests you capitalize all keywords and lowercase everything else. Separate the words and names with underscores. I don't like to do that myself, but if you like to do that, then do that. Start each clause on a new line. Break long clauses into multiple lines. Indent. Use comments. Make sure comments are correct and up to date. Remember, as it says here, line breaks, etc., have no effect on the operation of a statement. Now, this just basically says that you are able to use MySQL or Oracle or SQL Server and work on it with different types of programming languages, such as PHP, Java, C#, Visual Basic .NET, and there are other ones also. Don't worry about the MySQL drivers. All right. And again, I've already mentioned these terms to you. PDO stands for PHP Data Objects. JDBC stands for Java Database Connectivity. And ADO right there that you see is ActiveX Data Objects. Do you have to know that for this class? Not in the least. They show you a PHP example. I don't want to run through that. Java example, I'm not going to run through that. So that brings us to the end of the stuff we had in here for Chapter 1. All right, so next, and like I said, this is just really not making me happy. But next we will go into Chapter 2.